Greetings, School of Lifers, Woodsians, and business analysts. Welcome to another week wherein we discuss discovery and data collection in terms of my business analysis framework. As always, I've been doing simulation for a long time in the two major families of it, and that experience gave me the skills to understand business analysis and describe it in a way that is, I think, more approachable than some of the other ways it's described. I did this in a lot of industries for a lot of applications and covering many architectural considerations. As always, there are links. You see them in orange on your machine. They may not be, but definitely check around for things that are different colors. They lead to other materials either on my website or elsewhere on the internet. I've spent the last several weeks talking about my process and framework for doing this work, and it always involves iteration within each phase and between phases. So it fosters completeness and thoroughness and making sure all the work you do is geared toward the actual intended use. And it basically says, here's what we're going to do, here's what's going on now for the conceptual model, or alternatively, what pieces we're going to build the solution out of. What do we need? How are we going to do it? Is the design. The implementation is going ahead and building it and then testing it and doing acceptance. Welcome, Connor. So bear all that in mind as we go through this. I want to differentiate between discovery and data collection. Discovery is a qualitative process that identifies the nouns and verbs. So it's what is in the current process and what are the things that happen within it. That means the nouns could be different departments, different humans, different logical operations, and then the details are all the specific activities. So what you're doing is going from, we don't know what's going on, or there's a big blob, at least from the point of view of you as a business analyst, to a clear picture of what's going on qualitatively. And you're always doing this with the understanding of the problem you're going to solve. And I'll go into that a little bit in a few slides. So you do discovery first, so you know what data collection you're going to do. And imagine you're going to simulate or automate the process. What information would you need? So let's talk about data collection now. Once you know what's going on, you do the quantitative process that describes everything. This gives you your adjectives and adverbs. And that's how you go from understanding what and who and what's going on within the process to how much, how many, distributions, percentages, statistical, historical information, and so on. And there can be as much information out there as you can think of. So think about, imagine a car and think about all the things you might need to know about a car, depending on whether you're thinking of it in terms of traffic modeling, parking for some facility or other, service, actually providing service either at an inspection or a repair shop or a gas station, insurance, design, all these other things. The way you think about that car may be very different, and that'll drive the information you collect. So if we have an existing process or environment that we want to improve, or a product that we have that we also want to modify in some way, then we will start from the intended use and go ahead and figure out what's going on now. So we will build a conceptual model, and that's where we do discovery and data collection. Then we'll do requirements, design, implementation, and test. However, that is configured for the current project, whether we're doing waterfall or agile or scrum or any other weird configuration of our product or management process. Now, if we're starting from scratch, so there is no existing process, product, or environment, we'll do the define the problem, then we'll do requirements first, then we'll do the design, and within that, then we'll do the discovery and data collection. So this information always gets done. So like I said, you find out what's going on in discovery and data collection, and also learn about the components for potential solutions. And if we look at that as a flow chart, we'll say, okay, what do we need? What's the problem? If there is an existing process, then we'll go ahead and do the discovery and mapping for the as-if state. Otherwise, we'll skip straight to requirements. It's two ways of saying essentially the same thing. Oh, one other thing that's important. My framework, if you remember the beginning of this talk, always iterate. So even in these situations, intended use and requirements and conceptual modeling can all happen in almost any order you want. So I generally present them in this order just as a standard jumping off point, but there is nothing that says you cannot do requirements first. even if there is an existing situation that you're going to modify. So, like I said, it's always iterative. You may do some requirements at the beginning, then do all your discovery and data collection, and then you'll do more requirements, or you'll flip back and forth between them. So the framework is really about making sure you do the work, having situational awareness, and giving you guidance of things to do in each phase. And it's not intended to be a cookie cutter, do A, then B, then C. And that leads to fame and fortune, because that's not the way it works. So I usually talk about processes because that's my experience. And that's probably the largest kind of application for business analysis. But bear in mind that the same kind of analysis also applies to analyzing and developing products, and also your working environment within a company. So process mapping talks about what goes in, where it goes, how it's transformed, and what comes out. So if you imagine a process that kind of sits there, and then stuff comes in and it's processed and maybe it goes out. So this can involve information, material, and whatever entities you can think of. It's not just stuff, it's not just IT. It applies to a lot of different things. Now, whenever you connect to any of this stuff to external processes, environments, or anything else, there's going to be an interface of some kind with which, or across which, things are going to be exchanged. And what you define as inside your process versus outside is the scope. And of course, there is a link to another article about them. So maps should be presented at the level of detail that makes sense given the problem you're trying to solve. I'll go into more about that in a little bit. So process elements, each element or each processing step within a process might involve a whole sub-process with a map of its own. Sometimes it'll be just, an entity that moves through the process like a document or something, might get to a certain processing station, and then all kinds of complicated things could happen to it there. But whether we want to go into that detail depends on the type of analysis we're actually doing. So a lot of other data could be included: state data, timing data, statistical data, and so on. Entities moving through a process can be modified, they can be split, they can be combined, and so on. So if you're building a car, for example, or if you're making a coffee, you might put a whole bunch of things together. And you can also think about things being divided, and also if you're machining something, say drilling a hole in it or changing some piece of data, those are all things that can happen. So processes and entities may be continuous or discrete. I'll talk about that next week when I go into a longer discussion about how data is actually used. So today we're just talking about how it's collected. Some items may move within the system or be a permanent part of the system, but never leave. Even so, you're dealing with a process. For example, when we used to simulate aircraft logistics, we'd have a defined set of aircraft in a unit or a location, and they would always be in the system. They would assume different states, parts would come in and out, and different operations would be performed on them, but the aircraft never leave the system. So changes in state may be represented as movement, like I said, or by other means, changing colors. There's a lot of way you can represent these things in an animation. And you can include anything. I'll talk about the different views in a minute. So if you're trying to find out what's going on, if you're doing discovery, what you want to do is look at each process, figure out what all the inputs are and where they're coming from, and what all the outputs are and where they're going to. And there can be any number of these. So SIPOT, meaning source, input, process, output, customer, is a fairly standard abbreviation in this practice. However, I learned from a fellow practitioner that people often reverse that and think of COPUS, which is figuring out what customers actually need and working in reverse. So that's kind of a clever way to think about this. And if you are pulling apart a process, figuring out what's going on, and you don't have a guide or somebody to explain what's going on in order, or if you're trying to really determine how far the problem goes, then what you can do is talk to everyone and look at everything involved and then piece all the bits together. So the process you look at, the customer may be some other process and the source could be some other process. So if you stick all those together, you get your full operational scope. And if you talk to the right people, they're saying, okay, you forgot this, that shouldn't count, and so on. That's in, that's out of scope. So like I said, I tend to think in terms of processes, but we can also do all this for products and environments. So if we look at a gas station, how can we think of that as a process? For example, a car pulling up and refueling, maybe going into a buy stuff or ask questions or drop somebody off at work and then pulling out. Or the guy who's delivering all these snacks was checking with the person working the register, go ahead and offload the stuff, do some paperwork, and then leave. You can have all kinds of cleaning and maintenance. you can have the fuel delivery truck go in and refill the underground tanks. There are as many processes and products as you can think of. And how you look at it depends on what problem you're trying to solve. The same is true of business analysis. So the process of actually doing this work. And that can be a process, which is the engagement or the loops I always talk about. And also, it can be a product, the whole gas station, or different parts of it. And of course, the entire thing can be an environment. So we can, within any given larger system, drill down to any level of detail that we want based on what we're trying to do. So just looking out in the pump bay, we've got pumps, fire extinguisher, safety apparatus, emergency shut-off points or switches, window cleaning stuff, trash cans, a nice hard top. There's probably drains, there's a roof. There are all kinds of things we may or may not need to be concerned about. Drilling down even further, look at all this stuff just on the outside of a gas pump. There is a ton of stuff and it all serves a different purpose. Any one of those things could be part of a process of some kind, and that's just the stuff outside the pump. Inside the pump, there are pumps and valves and little tanks and measuring devices and electronics and communication and so on. So again, all that you gather information about it based on what you're trying to do. So here are some other considerations that you might want to look at when you're analyzing operations at a gas pump. If you're doing a facilities analysis, for example, and you only want to know what the throughput is, or maybe how many gas pumps you'll want to put in a location when you're designing it, then maybe you'll only care about the number of gas pumps there are, or the number of cars that or vehicles that each pump can service, and you only care about how long a car is parked at any of them and whether it's working or not, and all these details you don't care about. But if you're thinking about how to do a payment process for that or a maintenance process, then you'll gather all the detailed information within this. So again, and as I stress over and over, the data that you capture will depend on the problem you're trying to solve. When in doubt, generally gather it all and you can sort out what's going on later. And so that just says everything I said again. So if you look inside a process, this was for a disability underwriting, disability insurance underwriting business process I automated back in the early 90s. And if you look at a flow chart of all the stuff that documents flowed through, and in order to support an evaluation and scoring an ultimate decision of cover or no cover, we figured out all the different kinds of documents that could be flown through a process, and then all the different kinds of things each station or each group of workers could be doing it. And every column would be filled in, and every row would be filled in one or more stations. So these were all the entities and all the possible operations that could happen at any station. So again, you could look at individual processes from a top level or drill down as much as you need to, depending on what you're doing. So we can talk about states and diversion percentages to say, okay, when I come into a process, I'm going to do some initial decision or measurement or something, and then maybe different things are going to be done based on what happened there. And this is one way to represent that. There are many possible ways. So you should represent them however it makes sense for your system. And that's really sometimes things will be random and sometimes they'll be statistically driven, and sometimes they will be deterministic. So I know that when you cross the Mexican border or fly into Mexico and land in clear customs, there's roughly a 10% chance that they're going to do a further inspection. So either the inspector will push a button or you will go ahead and push it, and if the light turns red, congratulations, you're getting inspected. So there are random things that happen in processes too. And if you think about the experience of an entity moving through a process, we don't care how a machine part or something being assembled or document feels as this is happening, but we do care about people. And when we're analyzing people going through a process that is called service design, and I've included an article about what I learned from a presentation I saw. So process mapping can be done many different ways depending on the application and the industry. So I know most of us build systems and do IT stuff, but some of us have worked on control systems and manufacturing systems, and the same kind of analytical processes apply in many cases. So these connections are showing material flow, and there are different kinds of materials. So if you're making paper, you've got wood chips coming in. They have a certain amount of wood fiber and a certain amount of moisture or water in them. And as they go through different pieces of equipment, they will assume different temperatures, different mixes of water in pulp or water in wood fiber, and there will be different amounts of steam, different amounts of energy different classifications of sizes of fiber and so on. And these are all industry standard pieces of equipment. In this particular drawing, we show the amount of flow in the water pulp balance and something about the amount of energy. So the type of drawing you do will depend on what your need is, or sometimes you'll be learning things about a process from drawings. And there are many different ways you can depict a process. For example, this is a process and instrumentation diagram. So it only shows logically what's happening in the process, kind of from the point of view of what it's doing to the pulp and the water. But there are other drawings out there that show where these things are all located in a building, what their dimensions are, the nature of the piping, all the individual components. And again, there are different representations based on needs. And I won't go into so much detail on the others. This is for a nuclear power plant, the system of one of the systems I simulated had another page like this of stuff, and then another page with some support stuff. And if you notice, there's two of everything because nuclear power plants are highly redundant. So I got a whole career's worth of education doing this. This was the diagram we made in the simulation tool for simulating border crossings. This happens to be at Columbus, New Mexico, on the southern border with Mexico. Different kinds of entities, civilians or pedestrians, buses, privately owned vehicles, and commercial vehicles or trucks come in, get processed, do different things, and go out. And here's a generalized architectural study I was doing when contemplating putting a tool together. So you will find standard type of components in every process type system. For example, you'll have entries where stuff comes in, and you can characterize the what the operating hours are and what the nature of all the things that come in are, sizes, citizen type, document type, information, and so on. And then you've got exits where things leave a process. They get processed in individual stations where some work is done. And if you have a group of these in parallel that are all doing the same thing, you might call that a group or a facility. You've got queues where things wait, and they can be FIFO or LIFO or anything else. So a bag or a parking lot is a non-FIFO or LIFO queue, or it's a stack. And things can come in here, and in this case, one thing that happens in a parking lot is the vehicle parks and the people inside the vehicle get out and they do things in other processes. and they come back. So that is an example of an entity splitting in the middle of a process. So we're going to capture, so data collection is about characterizing what we've discovered. And again, it's quantitative information. So to mention volume, storage capacities, and so on, arrival and departure information, what goes where information, we always call that diversion percentages. So if you reach a decision point in a flowchart thing, 40% go to A, 20% go to B, 10% go to C, and 30% go to D. And I think I added that right in my head. So how long each process lasts, whatever is needed to describe transitions or modifications or state changes, storage capacities, again, other kinds of information, and so on. So that's what we're gathering. And again, I'll talk about specific data, the way we deal with it next week. So there's an observation technique in business analysis, and it involves basically how you find out what's going on, how you do discovery and data collection. So you can do a walkthrough, and that can be guided or unguided. It's often easier if you do a guided one led by an expert, so you make sure you didn't know anything or you don't miss anything. However, when I used to go to paper mills, I'd take drawings, find out where the chips would come in, and then I'd walk the entire process all through the plant, following the drawings. So that's how I got up to speed at every location. So you can look at drawings, documents, manual specs, and whatever. I talked about different kinds of drawings. I looked over hundreds of them when I simulated nuclear power plants. We can do all kinds of collection of electronic information. It can be ongoing, happening in real time. It can be historical. It can come from sensors. It can come from manually recorded notes. There is much of that stuff as you can imagine. You can actually sit and watch stuff and record it in real time. You can do interviews, you can do surveys with multiple participants. We can do photo and video. We took hours and hours of video of border crossings and airports and other things, and then broke that down to see how many people came in, went where, and how long they took. You can do calculations, and there are all kinds of other things you can do. So there are a lot of ways to collect information, use all of them. So how do we know how to do this? There are all kinds of domain knowledge. I'm talking from the point of view of generalized process or business analysis information, but there's also If you're working in a specific industry or with a specific technology, then you might need to know more information about these specifics. The more you know is always better. So in theory, a BA is a learning and translating machine that can learn everything on the fly, but as a practical matter, people need to be familiar with an industry, and they'll do a better job if they know more. So, this is what you need to know to understand what you're seeing in a process or product or environment. Analyze the operations. 5 people could look at things in something and see different things. So consider the parable of the elephant ear. There are certain specific calculations that can be employed in different industries. They can be physical, financial, time-based, and so on. And it's also a way, the more you know to ask questions so you don't miss anything. I always share this strong because I want to emphasize that you want to look at every component from every possible angle. And UML is one way to do this. The BABA doesn't talk about this. And again, that's the business analysis body of knowledge. It's a big orange book, at least in its current 3rd edition. That talks about other ways of doing things. So simulation is great for understanding things because you see visually if it does some kind of animated output, whether you've included everything or not. There are some situations where there are formal proofs of correctness and completeness, but not always. And the best way you know you got everything right is if your customer accepts the work you've done. So let's talk about UML. We're getting to the end. So a class diagram looks at every entity or station or element and whatever, and defines a list of attributes and actions. Now, if you're familiar with object-oriented programming, you have the abstract classes, and then you have individual instantiations and perhaps variations on that, and those are objects. So you have use case diagrams which talk about how users interact with the system as a whole or individual components within it. You have state diagrams which talk about the different situations the system or component can be in. And that means the things that move in a process or through a process, or things that don't move in process other moving entities. You can have sequence diagrams, activity diagrams. So the difference between those is sequence diagrams show an order, activities show a sequence of actions. And then a collaboration diagram relates items to events with the physical or logical stuff with what actually happens. A component diagram is like a functional description or block diagram of software components. And similarly, you could have a network or deployment diagram that describes all the hardware and networking stuff of the IT systems and instrumentation. And there are a bunch of other things we can have. So if you, going back to the previous picture, if you do all that, you're looking at the problem from many different angles. And if you do all those things, you're going to be likely pretty thorough. And there's one more way of doing this. Looking at the system using standard components, the way I often think about it, you look at every element, including all the users, supplies, timers, vehicles, stuff that moves through, entities, storage, and so on. And you look at everything that every quality of something that will affect its operation. So that could be location, it could be color, it could be classification, capacity, anything. And again, another way of saying the same thing, and think about which elements move and don't move. Whether something acts on other things or is acted upon, and that may be independent of whether it moves or does not move. States, sequences of events or states, timing and duration of all those, location and capacity, how elements can be grouped. So again, we have this facility. So we may have many things that do the same thing, or there may be a group that does very similar things, but each one is guaranteed or designed to handle a different type of processed entity. So if you think of inspections at a border crossing, some booths may be for privately owned vehicles, some for pedestrians and bicycles, some for buses, some for trucks, and some for oversized or dangerous load time vehicles. So there's a lot of ways to break that down. And you can also think about or analyze using kind of the affinity post-it method on a whiteboard to see what different things may have in common. So when you're you can build modular sections of your solution in a way that encourages reuse, modularity, consistency, and so on. And I think I pretty well reached the end. Let me go ahead. Okay. Do you have any questions? Thank you for being here.
No questions. Just need to go back from the start, I think. I think some of the patterns and pictures and all I need to get used to it.
Yeah, I mean, this is week 7. We've covered a lot of material, and business analysis is actually kind of a weird practice. Like I've told the other guys, if you say you're a plumber, everybody knows what you do. If you say you're a business analyst, nobody has any idea what you do. Things can look very different from many different points of view in different industries and so on. Go ahead.
How did you get involved with paper mills?
I am a mechanical engineer by training, and I also studied software. I went to Carnegie Mellon University, and that place was lousy with computers, even in the early 80s, right? So I always was interested in the interface between physical systems, engineering systems, and so on, in computers. And I got into a simulation on that job. I actually was a terrible student, ended up in the army for a few years getting my young stuff together. And then when I got out, I was more mature and kind of level headed. And that was the job I got. So it was in Williamsport, Pennsylvania. I traveled all over Canada and the US, and analyzed and did design for plants all over the world. So it was fascinating. And that kind of set me on a path to being a process analyst, process engineer, and doing simulation. I didn't go into college thinking that's what I wanted to do. That's just what ended up happening. So,
So
go ahead.
you got to work with PLCs and ladder logic for the
I
PLCs?
did. I didn't actually do that. I did that in the steel industry, which was my 5th job, 4th engineering job. And there is a kind of an established series of levels for control systems. So level 0 is the local instrumentation and control. Level 1 is the basic HMI or user controls of everything, and they'll have a computer screen and do all kinds of data archiving and communication and so on. Level 2 is supervisory control. So the level 1 spoke with PLCs and did all the low-level detailed control of the systems. And then my level 2 system that I specialized in talked with everything, passed data back and forth, and did model predictive simulation to send the control settings to the level 1 system. And then level 3 is plant-wide communications, and level 4 is the business and personnel and accounting type stuff. I also did desktop control systems using serial port controlled instrumentation that combine level 1 and level 2 stuff. So there's every combination of solution you can imagine out there.
Just for me, just coming into this, one of the things that I think subliminally flagged me away is my bias is I have a history in management consulting with Booz Allen, touching that company, and I don't have much regard for that industry broadly. And I think a lot of people view it as being misleading, or someone they pay to give the results, a company gives the results like they want, so they have someone to blame, or they don't really add much value. What you have here is quite a bit different. Now, knowing you more kind of personally, that's why I'm here. I knew that can't be quite right, but just that term business analysis made me think of something like management consulting, which with my biases, I'm like, oof, that's not a good selling point. But that's, again, very much from my background, as in I watch out for that. But just, yeah, this from a marketing standpoint, it just seems very different from what I expected, or not what I expected knowing you, but what I would have expected just hearing the pitch, the name.
Yeah, I cannot control what the term avoids for the industry. And that's part of the problem that the practice of business analysis has. A lot of people think a BA is a junior person. They only work in this phase. They gather requirements so the customers don't have to talk to the nerds and vice versa. Then they go away and do something else. Because of my experience and my interest, I've worked across the entire life cycle of multiple processes, projects, and programs, right? From the usually, almost always, in fact, from the point of view of a vendor or consultant offering highly technical, specific hardware and software and analysis and services to larger enterprises. So we did capital equipment for the paper industry. We sold to and installed in large paper mills. We did steel reheat furnaces for the metals industry, and also induction melting furnaces for the parent company that bought us. We did document imaging systems for a consulting company that did business process reengineering, HVAC control components for any campus or factory or buildings that had to control HVAC, environment, lighting, entry and access, and so on. So I always think about the full life cycle, and really, when I started learning about this practice, it really gave me insight as to where the bodies were buried in all the situations I was in previously. And I told this story a few times when I built nuclear power plant simulators at Westinghouse. And at the most we ever had under the roof at the same time was, I think, 3 different simulators in one. And we had 256 people tops in that division at that time. And I can't even remember where I was going with that. I have to look at the record again, figure out where the body is buried. All right. So, seeing no further questions for today, I will put the video up and the links on my website. Thank you for being here. Always happy to help with any of this stuff going forward for anything you guys are doing.
Good, thank you.
Okay.
Thank you.